Welcome everyone to .NET Enterprise Developer Day EMEA 2022. Thank you for joining us. It is my pleasure to introduce to you our next speaker, Andy Hopper, Worldwide Tech Leader for Microsoft Workloads at AWS. Welcome, Andy.
Thank you very much. Good morning, good afternoon, and good evening, wherever you are in the world. Thank you very much for attending this talk. My name is Andy Hopper. As we mentioned, I'm the Tech Leader for Microsoft Workloads at AWS. This session is going to be about, how .NET developers can easily deploy their applications into AWS. And what we'll be talking about during this session is, first, I'll give you a quick intro. Not all developers are aware of the fact that we have support for deploying into AWS, depending on what your development environment is. I'll talk a little bit about the history of .NET and AWS, and then we'll start diving into the actual tooling that we're going to be specifically talking about in this session. I'll talk about we've got a couple of different mechanisms for you to deploy your applications. We've got a command line interface or CLI tool that integrates with the .NET command line interface. We've also introduced a new concept of something called a deployment project using the Cloud Development Kit. Ulili will actually be talking about this a little bit later on today. So if you want to learn more about Cloud Development Kit, I definitely recommend that you attend his talk. Then finally, we'll talk a bit about the user interface, the GUI interface we offer for developers inside the Visual Studio IDE. And then, of course, I think demos speak more than 1,000 words. It's always better to actually see these things live than to just, do a lot of slideware. So we're going to be diving back and forth between the deck and me actually doing some live coding, and hopefully the demo gods will be working with me. Towards the end, I've got about 10 minutes of time for us to do Q&A. If you folks, have any questions, just put them in the chat window. Right now, because I'm sharing my slide deck, I'm not able to see the chat window, but once we're done with all the slideware stuff, I'll switch back to that window so I can actually see any questions that you folks may have. All right, well, let's get rolling here. So not a lot of people realize that you've been able to run Windows and .NET on AWS longer than a lot of the other clouds have even existed. So we've been actually able to run Windows and .NET workloads since 2008. And what this means for you folks is that we've got a lot of experience hosting and optimizing developers' workloads in our cloud. And what you see in this chart here is really just kind of indicative of what the progress has been for developers who are running .NET workloads on AWS. Of course, on the far left, you'll see we've got the ability for you to spin up a Windows VM. And with Windows, of course, you've got .NET Framework. But as you can see over time, we've added more and more support. So not just the ability to run a VM, but also to do things like run, SQL Server, or even have fully managed offerings where you simply hand us the database and we'll operate that database on top of a SQL Server engine for you using our relational database service. You also may notice that we've got support for things like Active Directory, SharePoint, Exchange, and as we've been developing these workloads and hosting them on AWS, we've in more recent times started to actually even swim upstream a bit. So it's no longer just about how you can host your applications on AWS services. It's also about, how we can make the development experience easy for developers. We now support, of course, the new open source, .NET runtime, which is distinct from the .NET framework. We've started offering tools to make it easy to port from .NET Framework to .NET Core or .NET. It's called the Porting Assistant for .NET. It's available free of charge from the AWS site. We've also offered tooling for doing things like containerizing applications. Let's say you've got an IIS-based application that's running on an app pool on a Windows server, and you just want to find a way to get that deployed on top of a container hosting platform. We've got the app to container tool you'll see on the upper right there that simplifies that process. And then finally, we've even started to add, the tools that we're going to be talking about today. How can we make it easier for developers to choose the right approach for running their workloads on AWS? So, I mean, at AWS, we're big fans of finding out what it is exactly you want to do and then helping you succeed in that. We form partnership with you, and you've got folks like me and other solutions architects who are here to advise you, based on what your actual business goals are, what it is you're actually trying to accomplish. And of course, you've always got the ability to do a simple relocation of your infrastructure. You just spin up a virtual machine. You've got a Windows box. It's just a Windows box. You can run your .NET applications directly on that, and you'll be done. That being said, you're not really getting the most benefit out of running in a cloud environment if all you do is what we call a lift and shift, where you move something just to another virtualization platform. To help with that, again, we've got containerization offerings, where if you want to take your .NET application, run it as either on a Linux container or even now on a Windows container, now that Windows supports containerization, we've got support in AWS for you to leverage that containerization platform to get that better speed of deployment and also better development experience. Because when you're running the application on the developer box, that exact same image is what gets deployed to the container hosting platform. And like I mentioned earlier, we've also got fully managed platforms for you to take advantage of. We've got a relational database service where AWS will engage in all of the care and feeding of your database server for you. You simply give us the database that you want to host on it. We take care of the backups for you. We take care of making sure that there's uptime on the box. We'll even do things like apply point release patches to the box automatically for you. You've got the ability to control when those things happen, of course, but the advantage to you is that you no longer have to worry about all the operational overhead of all of those tasks. Now, what a lot of developers are, looking to do is really start to modernize their applications. And we have a couple of sessions today that I think a couple of them already been held today about modernization of .NET applications. Again, using tools like the porting assistant for .NET, app to container. This allows you to take those existing applications and really retool them or refactor them so you can get the full advantage of the cloud, leveraging cloud native services as opposed to having to build all of that infrastructure yourself. We've got things like messaging queues, we've got databases, we've got NoSQL databases like DynamoDB, and we'll actually be looking at a demo on that in just a few minutes here. But we also have cloud native databases. We have a database technology that we call Aurora, which is a database engine that was built and designed to be hosted on the cloud. So it's able to take advantage of all the capabilities of those cloud native platforms, as opposed to shoehorning a relational database engine, hosted on a VM somewhere and just leveraging that technology. Now, with all the things I was talking about, you've got lots of options, lots of services that you can choose for hosting your applications. This means that there's a lot of choices that you need to make. What kind of application are you running? What is the expected hosting platform going to be? Are you running .NET Framework versus .NET Core or .NET? Are you trying to target, serverless deployment? And incidentally, whenever you hear us say serverless, of course, there are going to be servers involved somewhere. Really, the question is, who is managing those servers? So whenever you hear us use the term serverless, what that effectively means for you is that you don't have to engage in the care and feeding of the servers that are hosting your application's infrastructure. AWS takes care of all that. You get to focus on the actual business logic, the actual things that, the reason that your customers are using your service. Nobody's using your service because you're awesome at running a database, right? They are using your service because you're providing intellectual property. You're providing a benefit for them using your code. And so by moving to serverless hosting platforms, what that means for you is all the time you would have spent engaging in operational tasks, recovering failed boxes, doing backups, doing disaster recovery drills, that sort of thing. That all gets taken care of for you, so you can actually focus on the thing that actually differentiates your business from all of your competitors. Now, if you look at this is not a canonical, decision tree for all types of applications, but it's pretty representative of what a typical .NET developer would have. Obviously, of course, you've always got the ability to go to VMs, but you'll see, over this chart, we've got the option for you to move into containerization platforms. We have our own container hosting platform called Elastic Container Service. We also fully support Kubernetes. We've got a managed version of Kubernetes called Elastic Kubernetes Service. So based on, what approach you want to take, you can choose either of those hosting platforms. And then if you look on the far right, this is where people are really that's where a lot of more exciting development is happening, with people moving to serverless hosting platforms, such as our Lambda framework. It's effectively event-driven code. So you're responding to something happening in your environment. That something could be an incoming HTTP request. It could be a change in your AWS environment. We even leverage it in technologies like our CloudFormation or our Cloud Development Kit, which is our infrastructure as code deployment tooling. You also may notice on the bottom right, we even have support for what we're calling serverless containers. So it's still a container, instance that's running somewhere, but AWS takes care of spinning up all the infrastructure to host that container for you. And again, all you do is you hand us an image. We take care of deploying that image. You simply tell us how many copies of that image you want to have up and running, set up load balancing, that sort of thing. And then AWS takes care of all the care and feeding of those container instances. Now, with all the choices that you've got, there's also a choice of what kind of development environment that you work in. And AWS has done a lot of work to ensure that we target the most popular IDEs out there for developers who are writing their .NET code. Obviously, of course, lots and lots of developers use Visual Studio. It is a fantastic IDE. Microsoft has always been at their roots a developer, oriented company, and Visual Studio is, in my personal opinion, the best IDE out there, at least for .NET workloads. That being said, we also support other IDEs. For example, if you look on the bottom right there, there's a relatively new entry by JetBrains. These are the people who wrote ReSharper for Visual Studio. They've actually got their own IDE for .NET projects now. They call it JetBrains Writer. It's actually a really cool IDE. They leveraged all the experience they had writing ReSharper and their IntelliJ Java IDE, and they applied that to the C# code development process. Now, that's just the IDEs. Of course, you've also got Visual Studio Code. It has become widely the de facto platform for like web developers who are doing like JavaScript, HTML, client-side applications, that sort of thing. But of course, some developers are, they got their start in the Azure world. And so they've spin up a CI/CD platform on top of the Azure DevOps or ADO platform. And they like that development process. They've already got their CI/CD flow already set up. And that's, frankly, CI/CD is a lot like religion. Once you've got it, you want to stick with it. And so we actually have a toolkit that allows you to deploy into AWS from within Azure DevOps. And then, of course, sometimes when you're doing deployment or doing development, you may have repetitive tasks. And PowerShell is now a fantastic, platform. It now can be deployed to not just Windows, but you can run it on Mac OS, you can run it on Linux. And we've got great support for PowerShell as well. We've got commandlet tooling for PowerShell. You can simply install them from the NuGet providers into your PowerShell environment. Incidentally, we even have support for PowerShell in our own systems management tools. We've got a service called Systems Manager, and you can literally run PowerShell documents on your instances rather than having to write, command shell scripting or bash or whatever, depending upon the target operating system. All right, so let's talk a little bit about the deployment process. So with .NET, the .NET Core world, this got started using the .NET CLI. And so we've actually created a global tool to be installed in the .NET CLI to enable you to automatically deploy your application into AWS. And this is really important. And rather than you having to learn about all your options or having to go through that chart that I was showing you earlier with all the decision tree paths, what the .NET CLI tool will do is actually inspect your project, and it will actually make recommendations for what we think the best hosting option is based on the technologies that you're using. Now, we've got a lot of different choices. Again, like you saw in that chart, we've got things like Elastic Beanstalk, we've got container hosting using App Runner. We've also got our Elastic Container Service or AWS Fargate. If you're running a Blazor application that needs web hosting, rather than spin up a server, you can actually run a web application and host it on top of our simple storage service or S3 inside a bucket, and then expose that to the outside world either directly through S3 or by using our CDN network that's called CloudFront. And then lastly, depending upon, the kind of project, if you're targeting serverless technologies, we also support deployment into AWS Lambda. Now, in all of these cases, again, based upon the analysis of your project, we're going to give you what we consider to be a best practice deployment for that project. And that includes leveraging infrastructure as code. So if you're not familiar with the concept, the whole idea with infrastructure as code is rather than going through ClickOps and navigating through a browser-based interface or going into the AWS command shell and then manually deploying or provisioning resources, what you do instead is you craft a document. Now, in its original form, infrastructure as code here at AWS was done using a technology called CloudFormation. And that was a JSON or YAML file where you described all the infrastructure that you wanted to host your application in. You handed that template off to CloudFormation, and then it would construct all the infrastructure necessary to do it. However, in the most recent years, we've now created another deployment technology. We call it the Cloud Development Kit. And again, Lily is going to be talking about that a little bit later on today. But at the end of the day, it's still code that can actually be checked in alongside all the code that your application uses. And that way it can be version controlled. You actually have the ability to download the repo and you get everything you need, not just the application code, but even the ability to deploy it into your AWS environment in one fell swoop. Now, like I said, we're going to be doing a few demos, and this is my favorite time of day, which is demo time. So what we're going to do is we're going to switch over into my PowerShell command prompt. And what I've got here is actually just a demo project. Actually, I'll switch over to Visual Studio for a second. It's got three components to it. It's got a DynamoDB table that's actually hosted in AWS. And I'm just basing this off of Microsoft's own weather forecast sample application. I've got a backend. This is actually a REST API. And then I've got a Blazor front end. And so what I would like to do is inside my .NET CLI, I'm going to go ahead and do .NET AWS. Oops, hang on a second. I need to actually switch to one of my projects. And I'll do .NET AWS deploy. Now, what the tool is actually doing is it's inspecting the project structure. It's seeing that this is a REST API, it's using Web API. And now what it's doing, if you can see in my command window here, it's actually recommending that I host this application using Fargate. Now, in this particular case, I've got my backend set up. Again, it's just Web API, and I'm using the minimal, this is .NET 6, so I'm using the minimal syntax to spin up my Web API. But you may also notice that I've even included a Docker file. So I have the ability to actually generate the container. What the tool did was it noticed that this is Web API. It sees that it's .NET 6. And so it was able to recommend that, hey, you could run this as a Linux container on top of our serverless container hosting platform, AWS Fargate. Now, incidentally, if I hadn't already written this Docker file, the tool actually will generate a Docker file for you. So if it detects that it's something that can be containerized and it does not yet see that you've got a Docker file, it actually can go through the process of actually creating that Docker file, and then it will use the local Docker build tools to actually construct that container image. Incidentally, this is a really good time for me to talk about the prerequisites for running the .NET, all of the deployment tools that we'll be talking about actually. Because this is able to do things like, generate container images, if you do intend to target container hosting, you'll need to have the Docker toolset installed on your box, because that's the way we'll actually invoke the Docker build commands to actually create that container image. Once we have the container image, we can then deploy it into AWS, but it still has to get generated, and it will be generated on your box. The other one that I mentioned earlier is that because we're leveraging the Cloud Development Kit, or the CDK has a dependency on Node.js. So if you haven't already installed the CDK on your machine, you'll need to go ahead and get Node set up and install the CDK. It's downloadable from the NPM repository. And once you've got all that set up, then you're ready to go ahead and actually leverage the .NET CLI tool, as well as the Visual Studio integration, which we'll be looking at in a few minutes. Now, in this case, I don't want to go ahead and deploy the project quite yet. We'll go ahead and do that through Visual Studio, but I wanted to at least show you, how you actually get access to the tool. Incidentally, I did want to point out like I showed you in the slides, if you want to install the tool, it is a global tool. And so you just install it as .NET tool install global, just to make sure it's installed globally. And then the name of the tool is aws.deploy.tools. Once you get that set up on your machine, you're then ready to start using that command line interface to start deploying your projects. All right, so let's get back to our slide deck. Now, another addition to that .NET command line interface is something we're calling deployment projects. So I mentioned earlier, what the deploy tool will do is actually will generate a CDK project for you to deploy your application. Sometimes, you need to have resources that may not necessarily be codified inside your application. Maybe you've got other infrastructure that you'd like to have in place that is a dependency of your application. I talked earlier about how this demo project is using DynamoDB. So if I wanted to have it to where that DynamoDB table was created as part of my overall deployment so that I can deliver everything all at once, what I can do is generate a deployment project and then customize that deployment project and add whatever resources I think are going to be necessary for my application. And the way you do it is just as I navigated to the project folder to run the AWS deploy command, you can do the exact same thing, navigate to your project folder and run .NET AWS deployment project generate. And what it will do is, again, inspect your project. It'll give you the same set of recommendations that you would get if you were just doing a full deployment. But what it will do instead is create a deployment project for you. And that will be a CDK project that will be in a sibling folder of your project. And we'll take a look at how that works in just a couple of minutes. But the whole idea is that, now that you've got your deployment project there, it's a full-fledged CDK project. You're literally doing infrastructure as code because the CDK can be written using C# code. And you just simply load whatever other resources you want to have deployed into your AWS account inside that CDK project. So let's take a look at how that works. So what I'm going to do here is I'm going to go ahead and run .NET AWS deploy generate. Actually, I'm going to save myself from fat fingering. There we go. So I'm going to up arrow to my command here. What I'll do is I'll run that .NET AWS deployment project generate. And what it's actually doing, again, is it's running the same analysis. You'll notice I get the same set of recommendations. And in this case, it's, again, giving me the recommendation to run it on Fargate. So I'll go ahead and choose deployment option 1. But rather than actually starting the deployment process, it's simply creating that back-end deployment. So let's actually take a look at what that looks like inside Visual Studio. So I'm going to go ahead and add an existing project. And in this case, it is my deployment demo. And if you look in, oops, hang on just a moment. I picked up the wrong one. I want that one. So you'll see I now have a backend.deployment folder. And if I load that into my solution, you'll see, this is a CDK project. So again, we're going to be talking a little bit later today about how the CDK works and how you can write C# code to deploy infrastructure into AWS. But just to give you kind of the nutshell overview, what it will do is actually create a C# project for you. It has a dependency on the Amazon CDK. Let me make that a little bit bigger. And in this case, because we've chosen Fargate, it's actually going to use ECS or Elastic Container Service resources. So there's a set of things called constructs in the CDK that allow you to deploy resources into AWS. And what we're doing in the deployment tool is we've built recipes that are built on top of those constructs. So based upon the kind of project you have, that's what enables us to choose the correct recipe. And then based on those recipes, we'll actually spin up the infrastructure necessary directly inside that CDK project. And for those of you who are not familiar with CDK, you simply new up whatever resources you want inside your code. The CDK interpreter will actually run your code, and it will generate a CloudFormation template for you based on the infrastructure that you've actually got inside the CDK. But I'll leave the rest for a little bit later on today. Now, one other thing I do want to point out is when you do run that deployment generation process, it'll actually create a new file in the source project, the one you actually ran the tool in, that's called aws-deployment.json. This is what is used by the deployment tool for it to know which CDK project it should use when deploying your application. So you don't have to navigate to that backend deployment folder to deploy your code. Instead, you simply navigate to whatever project you generated that deployment project for, run the AWS deploy command. It will then proceed to compile and execute that CDK stack and then deploy that infrastructure into your AWS environment. Now, in this case, I want to go ahead and start with the tabula rasa when we go to deploy this from Visual Studio. So I'm going to go ahead and nuke this. Incidentally, make sure you check this into source control. You'll see I've got get going here, and so I've got the little addition symbol there. If you want the deploy tool to be aware of the fact that there's a deployment project for this project, you do need to make sure you check in that AWS deployment JSON file. I might go ahead and remove this. Okay. Now, and this is going to be pretty much the star of the show. It's what we're going to be spending the rest of our time here on. We also, I mentioned earlier, we've got a toolkit for Visual Studio. And what we're doing now is we've actually released a preview of the same deployment tooling that I was showing you from the command line interface directly from within the Visual Studio IDE. It's available. I'll show you how to install in just a couple of minutes here, but it's available from the Visual Studio Extension Marketplace. It's free of charge. You simply download it and install it into your AWS environment. Oh, and I should point out, hopefully it goes without saying, but for all of these deployment approaches, you do need to have an AWS account and permissions to deploy your infrastructure into AWS. You can't do anything in AWS without the proper permissions. It's a security measure. So do make sure that you've got a user that has the necessary permissions to do things, depending upon what deployment platform you use, Fargate container instances or Elastic Beanstalk instances, et cetera, et cetera. Now, the toolkit for Visual Studio, we currently support Visual Studio 2019 and 2022. Incidentally, if you do want to run .NET 6 code, Microsoft has restricted .NET 6 development to Visual Studio 2022. But again, we have support for the toolkit in both of those IDEs, and the functionality is identical between the two of them. Really, the only difference is whether or not you're running .NET 6 code. What the toolkit will do is add a few custom windows and some context menus to your projects. We'll take a look at what that looks like in just a couple of minutes here. But at the end of the day, it's actually consulting the same engine that the .NET CLI is using to deploy your applications. What we actually do is we spin up an instance of that .NET CLI under the covers as a shell process for Visual Studio, and that way we get to leverage one set of recommendation engines as opposed to having to replicate that inside Visual Studio as well. Incidentally, both the command line interface and the Visual Studio interface allow support the customization of the settings for your deployment. Frankly, I think it's a bit easier to customize those settings from within Visual Studio. There are cases where it's easier to just navigate through a GUI than it is to have to do everything from the command line interface. But this allows you to do things like select what IAM role, again, permissions that your code will be running under to allow it to talk to other AWS services. It allows you to do things like, select or create a VPC or virtual private cloud to host your application. It even allows you to do things like customize the application name. If you're targeting, say, Elastic Beanstalk, Elastic Beanstalk supports this construct of environments and applications, and so you can customize the settings on that. And of course, you can even do things like tweak environment variables. Maybe you want to have a trace flag turned on or something like that. And there are many more. It's going to depend on the kind of deployment methodology you're using. But if you go into the customizations of settings, and we'll take a look at that in just a minute, it'll give you a lot of options for how to actually change the options that you use for your deployment. And it's time to go back into demo land. So what we'll do here is I'm inside my Visual Studio solution. And again, I've got my backend. Let's go ahead and just run this so you can see what the sucker looks like. Oops, hang on. That's the Blazor project. Let me go ahead and run the backend. So this is simply, like I said, it's a web API interface. Again, I'm using the nifty new minimal API tooling that you get with .NET 6. But what it's doing is, the default project template gives you a Swagger user interface for that REST API. So I'm actually going to go ahead and just do a quick demo. This is actually hitting the DynamoDB table under the covers. And so what I'll do is I'll try it out. I'll run it. And so I've got the JSON response from my web API here in the Swagger testing user interface. But I'd like to actually go ahead and run this inside AWS as opposed to running it locally. So let's go ahead and do that. So I'm going to go ahead and close this window. And I will stop debugging. And what I'm going to do here is I'm going to leverage the new user interface that we have for deployment inside Visual Studio. Now, if you are familiar with the AWS Toolkit for Visual Studio, you may have already seen these options, the publish container to AWS or publish to Elastic Beanstalk. These have actually been there for quite some time, but this new preview user interface, which is leveraging that deployment tool, is now using the new title of publish to AWS. Oh, and lest I forget, I wanted to mention to you how you can install the toolkit. If you don't already have it installed, you simply go to the extensions menu in Visual Studio 2019 or 2022. You'll go to Manage Extensions. And if you search for AWS, it's going to be the first hit that you get back. And so again, in this case, I'm running Visual Studio 2022 because it's .NET 6. If you're running 2019, you'll just see it as for Visual Studio 2019. Incidentally, I didn't mention this earlier, but that porting assistant I was talking about to automate the conversion of your .NET Framework code to .NET Core, that's also available from the Visual Studio Extensions Marketplace and allows you to actually perform that refactoring from within the Visual Studio IDE, which is a really cool feature. Now, in my case, I've already got the toolkit installed. So what I'm going to do is I'm going to go ahead and right-click on my backend project, and I'm going to click on that Publish to AWS. Now, again, all this did was it spun up an instance of the deployment, the CLI deployment tool in the background. It then handed the project off to the CLI tool. And you'll see it's giving me the same set of recommendations that I was getting when I was running it through the CLI. So in this case, you'll see I've got a deployment project for backend to Elastic Container Service, or I can just go ahead and directly deploy this into Fargate. Now, what it's recommending is that I go ahead and generate the deployment project so I can customize it. In this case, I'm actually going to go ahead and just select the deployment to Fargate just in the interest of expediency here. Now, I mentioned earlier that this project is talking to DynamoDB. And again, you can't talk to any other AWS services unless you've got the necessary permissions. So what I need to do is customize the role that my Fargate task is going to be running under. And so what I'll do is I'll edit the interface. By the way, I need to show that to you folks again. Let me go ahead and pull this UI back up. Let's close this and we'll reopen it. I didn't do a great job of showing you. There is a hyperlink for edit publish settings. Sorry, I can't zoom in on this any further. But if you click on that hyperlink, that's what brings you to this user interface where you can do any customization that you need to for your app. In this case, the only thing I need to do is ensure that I've got the identity and access management role configured properly to allow my Fargate task to be able to talk to DynamoDB. And so what I'll do is I'll say I want to choose an existing role, because I've already defined a role to allow access to my DynamoDB table. I'm going to go ahead and browse it. And what I'll do is I'll search for deployment. And there it is, deployment tool, DynamoDB access role. This was actually created earlier in my AWS environment when I created that DynamoDB table. I'm going to go ahead and click OK to assign that. And that's really all the customization that I need to do. But you can see down here, you've got the ability to make any other customizations. You can tell it to create a new ECS cluster. You can also do things like customize the name of the service that's going to be running inside Fargate, as well as just select, where you want that Fargate task to be running. In this case, I'm going to go ahead and choose the defaults for all of those and go ahead and click on the publish button. Now, what's actually happening now is we're actually running the Docker build commands to actually generate the container image for my application. Once it actually generates the container image, it then deploys it to our Elastic Container Registry. And once it's got it uploaded into ECR, then it is able to actually define and launch a Fargate task that's going to be using that container image. Now, this is going to take just a couple of minutes. So while we're waiting, I'm actually going to take advantage of our kind of enforced pause to show you a few other features of the toolkit, just to give you an idea of what the power of the toolkit is bringing to the table for. So now, if you have installed the toolkit, what you'll see is that it's also installed a few additional things. Not only do you get the context menus for your projects, but you'll also see there's a new view inside the Visual Studio IDE called AWS Explorer. Now, what AWS Explorer allows you to do is navigate the resources that you have inside your AWS account from within the Visual Studio IDE. And this is great because it means now I don't have to context switch back and forth between my development interface and a web interface where I can navigate through all the things that have been created. So in this case, we offer support for all the major things that a .NET developer is likely to want to use. We've got the ability for you to navigate the virtual private clouds that you have inside your environment. We've got the ability for you to, inspect all the EC2 instances that you have. I'm a little EC2 instance happy in this particular environment. But it also allows you to do things like take a look at your DynamoDB tables. So in this case, I've got my deployment tool weather table, and just by double clicking it, it automatically downloaded some of the data that I've already got in that DynamoDB table. So again, this is a fantastic way for a developer to keep their productivity and stay inside that Visual Studio IDE experience without having to lose their focus. All right, so let me close these. And so we are still deploying, but what you may see down here is now that I've already generated my container image and I pushed it to the Elastic Container Registry, you'll see down here that we've actually generated our deployment project, and now we're actually using the Cloud Development Kit to actually upload this into my AWS environment. And in fact, if I switch to my browser window here and I search for backend, if I could spell backend, hear that. So it has not yet started the deployment. That's what's going on. So I was impatient. So what's actually happening right now is it's actually generated all the infrastructure necessary for my application. It is being deployed into US East 1, and the name of the stack is going to be, let me see what I used for it. Yeah, it's deployment project for backend. So there we go. Now it's deploying. So it's creating the CloudFormation change set. And in just a couple of seconds here, we're going to see, bear with me a moment. I'm just waiting for it to update. This is one of the least favorite things about demos. There we go. So it's actually started. So now if I go back into my CloudFormation console, there we see our backend is now starting to deploy. So this is the really important part, right? So while I wrote, or you can write your CDK projects using C#, it does get translated at deployment time into CloudFormation syntax. But that's not anything you have to worry about. You get to stick with the language that you know and love, namely C#. But what's actually happening under the covers is it is currently deploying the CDK project into my AWS environment. And if you want, you can even see the CloudFormation template that got generated by the CDK. Again, there's really no need for you to actually inspect this because it'll get automatically generated at deployment time. But sometimes it's good to kind of look at it as like a reference architecture just to see how the actual CDK tool is doing it. So what we're doing right now is we're just waiting for the deployment process to complete. What it's doing is defining that Fargate task. It's uploading it into my, or excuse me, creating it in my AWS environment. And in just a couple of minutes, I'll be able to access my REST API. One of the things that will actually be a result of this deployment is it'll actually give me a URL that I can access to actually see my REST API running inside my AWS environment. So while we're waiting for this, I'm actually going to switch over to the chat window and see if anybody has any questions. There we go. All right, no questions. So let's go ahead and we have to be a little more patient while we're waiting for it. As you can see right now, what it's doing is it's actually creating that Fargate instance. It's deploying that Fargate instance into my AWS environment. As a matter of fact, if I switch back over to my AWS environment, I may even be able to see it being generated now. So if I go to Elastic Container Service, I've got my backend cluster. This is the one that's actually that was generated by my backend deployment project. And so, yeah, I don't have my service up and running yet. It's just waiting for the task to be defined and then instantiated inside Fargate. So while we're waiting for the backend to complete its deployment, let's actually go ahead and take a look at the front end for my application. As I mentioned, this is a Blazor application, and so it's a Blazor WebAssembly application, I should add. And so what I'm going to do is I'm actually going to go ahead and run this inside my Visual Studio window, just to kind of give you a flavor of how the application actually works. Now, for those of you who aren't familiar with Blazor WebAssembly, what it is a client-side framework. You actually download all the JavaScript necessary to run your WebAssembly project to the user's browser, and then it actually executes from within the browser. Now, in this case, I'm just using the standard template. I've themed it up a little bit and put the AWS logo in it. But what I have done is put a fetch data page in my Blazor WebAssembly app. Now, because I'm in debug mode right now, this is actually using the default template for Blazor WebAssembly. So it's actually just pulling it from a JSON file that's inside my project. That being said, if we close this and take a look inside the Solution Explorer, if we look inside my app settings, it'll actually go to a URL for the data as opposed to that static JSON file that I've got baked into the www root of my application. So let's go ahead and check on our deployment here and see how we're doing. We are almost done. We're down to 13 of 15. So what it's currently doing, again, is it's created the Fargate task. It's actually spun up a task. And you may also notice that it's also created a load balancer for my application. And so this load balancer is going to be the URL that I use for my front end project. And so what I'll do is I'm actually going to go ahead and copy this endpoint. Here, I'll just click it. I'm going to go ahead and open this in Edge. And there, now I can just copy this. So it's going to be API weather forecast. And there we go. So this is a JSON that's actually being delivered by my Fargate task over that load balancer. So what I'm actually going to do is copy that URL. And what I'll do now is I'm going to go into my front end and I'm going to deploy that. So I'm going to go ahead and go to the publish to AWS preview feature again. I'm going to close the AWS Explorer window. And so you'll notice this is a Blazor WebAssembly app. The only recommendation we currently offer for Blazor WebAssembly is that S3 plus CloudFront hosting that I was talking about earlier. However, because I want this to communicate with my REST API, as opposed to talking to that JSON file, I'm actually going to go ahead and edit the publish settings. And you'll notice one of the options that we have here is the ability to enable a REST API. And so I'm going to go ahead and click on that enable button. And so what it wants me to use is the actual URL to my REST API. And you also may notice because I'm using CloudFront supports the concept of multiple origins for the same base CNAME for a site. And so what I'm actually telling it to do is deliver not only my Blazor WebAssembly app through CloudFront, but I'm also delivering the REST API content through that same CloudFront CNAME. However, to do that, I've got to tell it what the relative path for that other origin, that REST API origin, is going to be. And so in this case, I'm just going to go ahead and tell it that anything that goes to the /API resource should be directed to that REST API backend. All right, and that's the only thing that I need to do to enable my Blazor front end to be able to communicate with that backend. So what I do is go ahead and click on Publish for this. And similarly to that Fargate deployment, it's doing all the same things. It's compiling all of my code. It's standard C# compilation. So if there are any errors in your code, of course, the deployment won't proceed because you have to fix the errors first. But then it'll also generate a CDK project for my front end. And then it will actually synthesize that CloudFormation template from that CDK project and then deploy everything into my AWS environment. Now, in the interest of time, we may not be able to get all the way through the deployment before our time is up. But at the end of the day, what I'm going to get is a CloudFront URI, which is going to be the actual location of my CloudFront distribution. That's going to expose the Blazor front end. And what it actually will do is go to the default page, which is index.html, which is actually what's being exposed inside my front end project. But when my front end project attempts to call the backend URI, it's going to use that /API/weather forecast path, and it will get routed to that backend that I'm hosting inside Fargate. All right. And incidentally, I should point out, when you are compiling for deployment using the UI or even the deployment tool, will generate a release configuration of your project. And that's what's keeping me from using the static a JSON file. And instead, I'm going to the actual REST API backend. All right, so I'm going to go ahead and close the backend. And we will just have to be patient and wait on the front end. It's the deployment process for S3 is actually quite fast. All we're doing is we're taking all the content that we deployed from your Blazor WebAssembly publication process, the same content you would have gotten from a .NET publish command. We then deploy that into an S3 bucket. We'll then create what's called a CloudFront distribution, which you can see here. That actually will generate a new CNAME that's going to be exposed over HTTPS to the outside world. And what it will do is set up a private origin for that S3. This is really important. So what we do not do is expose the contents of the S3 bucket we create to the outside world. What we do instead is we set up that CloudFront distribution, and then we directly connect that S3 bucket to the CloudFront distribution so that the only way people could access any of the content for that Blazor WebAssembly project is through that URI for the CloudFront distribution. All right. So yeah, based on timing, I don't think we're going to go all the way through the deployment because it takes a little while to actually populate the CloudFront distribution. So what I'm going to do now is switch back over to the chat window and see if anybody has posted any questions. Awesome. So thank you, Irmaya. Yeah, we tried really hard to get that kind of integration within Visual Studio. Surprisingly, not all developers out there even realize that you've got the ability to deploy to AWS from within Visual Studio. Normally when you right click on a project, you'll get deploy to cloud, or publish, that is. And of course, Microsoft wrote the tool. So of course it wants to deploy to Microsoft Azure. It's their cloud. However, again, free of charge, you can download the AWS Toolkit. It takes literally seconds to install inside Visual Studio, and then you're up and running. And again, you've got the ability to not only do the publication into AWS, but you've also got project templates. Actually, I can pull that up real quick while we're talking about that. So while we're waiting for this deployment to go through, I'm going to spin up a new instance of Visual Studio. And I just want to give you guys a quick preview here. So I'm actually going to go ahead and tell it to create a new project. And so just for the sake of, grins and giggles, I'll tell it that I want to create a serverless application. So I'm going to search for serverless. And what you see is a whole bunch of project templates that the Toolkit installed inside Visual Studio for you. And these are just great ways for you to bootstrap your application development, right? So what I'm going to do is I'm going to go ahead and tell it. Now, I still haven't learned F#. One of these days I'll have to get down to cuddle up to it and learn functional programming. But what I'll do today is work on the language that I'm already familiar with. So I'll tell it to make a serverless application using C#. I'll give it a name. And I think I've already got a serverless demo, so I'll name it serverless demo 2. And what you'll see is it gives you this concept of what we call a blueprint. So it gives you a whole bunch of different, templates to bootstrap your project. And since this is .NET 6, I even get the new and sexy minimal API. So I'm going to go ahead and tell it to use the minimal API, and I'll tell it to finish. And all it's doing is automating the creation of that C# project for my Lambda. And if you look here, I'll see, this is my program CS. And if you look inside it, you'll see it's the minimal API that we got with .NET 6. I also get the controllers that actually are going to be hosting the actual web API controllers in my project. And if I wanted to deploy this into Lambda, I can simply right-click this, and you'll see I've got the option to publish it to AWS Lambda, and then it will automate the creation of the Lambda, deployment of the zip file necessary to host all of my code, and then even spin up a API gateway to allow me to access the content in that Lambda from the outside world. All right, so we are at time. So let me see, nope, we weren't able to bring this in under the wire, so it wasn't able to complete before our time is up. But what I did want to do is pause for a bit more and just see if anyone else had any other questions. And if not, again, thank you all very much for attending this session. I hope this was useful to you. Again, you can install the pre-release of this deployment tool, both inside the .NET CLI as well as inside Visual Studio. Simply go to the extensions marketplace and install the AWS Toolkit for Visual Studio. All right, I'm going to stop sharing just so we don't get like infinite windows, but I'm going to switch back over to the chat window and don't see any other questions. So with that, I believe we are at time. And again, I just wanted to thank you all for attending this session. Again, I do hope this was valuable to you. If you do have a chance, I strongly recommend that you attend Lily's session on the CDK, just because it's a really useful technology, especially for us .NET developers who want to code everything inside C# instead of having to learn a text-based language like YAML or JSON to do our infrastructure deployment. All right. Well, with that, again, thank you all very much. I hope you enjoy the rest of your time here at this conference, and we can't wait to see what you build on AWS.